Hello guys, welcome back to my channel. In this video, I'm going to take you through the number system conversion that is on octal to hexadecimal conversion, and the steps are quite simple and straightforward. So number one, you convert the given number to binary. Then from that number, the one that you have converted to binary, you convert the binary number lastly to obtain the hexadecimal. I'm going to take you through several examples so that you can get yourself conversant on how to convert an octal to hexadecimal. So before we dive into the example, we need at least to, to know something small on the binary, the octal, and the hexadecimal. And for the binary, this is a base 2 number system that exists with two digits, that is 0 and the 1. While for the other one, for the octal, this is a system that uses 8 digits, that is from number 0, 1, 2, 3, 4, 5, 6, and lastly the 7. While for this other one, for hexadecimal, which is now a combination of decimal, which is a combination of decimal with other digits. And for this one, it is a system that has 16 digits. That is from 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Then from the 9, remember the decimal is supposed to be from 0 to 9. Then we have from 9, we have the A, B, C, D, E, and F. For the A, it stands for 10, B, 11, C, 12, D, 13, E, 14, F, 15. Okay, because of time, let's move to the example directly so that to avoid wasting a lot of time. So our number, we have 26 base 8. So as per the rule, you convert the number. So you need to convert the number first to binary. So we have the 2. This is a 2. And the other side we have 6. So the binary for 2 is a 0, 1, 0. Well, that of 6 is a 1, 1, 0, just as you can see from the tables of conversion. So what I have 0, 1, 0, 0, 1, 1, 0. Okay, having done that, the next step is to convert now the binary number obtained to hexadecimal. So what I'll do, I will combine this one to 0, 1, 0, 1, 1, 0, base 2. There goes my binary number. Okay, having my binary number, the next step is now to convert that number to what you call the hexadecimal. And for the hexadecimal, we'll have 4 digits. So we'll group it in 4 digits. So I will have the first group from 0. So we'll have this bunch. And if you look at the right hand side, the numbers of 0 that we have 0 and 1. So since we have 0 and 1, what you are supposed to do, you are supposed now to add other 2 zeros so that we can add 4. So I will add 0, 0 so that we can have another bunch. So from the tables of conversion, you will find that for this one, I think I should share with you the table of conversion. For 0, 0, 1, this is equivalent to 1. For 0, 1, 1, 0, it's equivalent to number 6. Okay, so the final answer will be 1, 6. Then the base is 16. So this is my answer. I hope up to that point we had together. Step 1. convert the number to binary. Step 2, group them in group of 4, then you extract your hexadecimal from the binary of groups of 4. Okay, let's move to our example 2, where we have 7231 base 8. So as usual, I will convert these on. So I will write down the number, which is 7, 2, 3, and 1. Then I will write down the binary equivalent of each. For this one, this is 0. Let me start from the 7. This 7 is a 1, 1, 1. For the 2 is a 0, 1, 0. For the 3, we have 0, 1, 1. For the 0, we have 1, 0, 0. Okay, having done that, I will combine the numbers to 1, 1, 1, 0, 1, 0, 0, 1, 1, 0, 1, 1 base 2. So what we have done, we have converted our binary number, our octal number to binary number. So in groups of for the one is supposed to be 0. Sorry for that. So this is 0. Make correction on that. Okay, make correction on this one. This is kindly make correction on that. This is supposed to be 001, therefore this is 001. Then this is base 2. So in groups of 4, we have the first group we have from this point, another point we have this one, and our last point we have that other part. So from the binary to hexadecimal, 1001 is equivalent to 9, while 1001 is same as 9, while 110 is equivalent to E. Therefore, the final answer will be E 9916. That is our answer. Okay, let's move to our next example, where we have the 70. For this one, I would want to introduce now the table where we have the hexadecimal. So let me do that so that we can make our work easy. So okay, so here we have the hexadecimal. Okay, then for this one, this is a 0. This is a 1, 2, 2. Then we have 3, 4, 5, 6, 7. Then we are supposed to have additional 0 here. So we have a 0, 0, 0, 0. Then for number 4, supposed to be 0. Number 5, we have 0. Number 6, sorry, 0, 7. So we are supposed to add a 0 on the left hand side. So let me try to add another table below this one. Let me see whether it will be possible to do that. Okay, insert a table. Oh my god. Oh my god. Okay, let me try to draw it manually. Okay, is my table draw. So there goes my table. Let me introduce another. Let me see whether it will be possible to introduce. Okay, so we have the 8, 9, 9. Then we have hexadecimal. We have A, B, C, D, E, F. Well, for the 8 is equivalent to 1000, 9, 101, 101. Then the other one we have for the A, 10, 10, because the number is of course 10. Then we have 10, 11. The second digit is the most important part. That is 11. Then we have for the 12, 1100, 13D, 10, 11. And for the E, we have 1, 1, 1, 0. And lastly, the F is 1, 1, 1, 1. So for the 0 is 1 is 0, 0, 0. For the F is, well, for the octal we have from 7 we have 10, 11, 12, 13, 14, 15, 16, 17. Sorry, 17. 17 is our last digit. So for this other example where we have the 70, so I'll write down the number. We're having this table make our work easy. Okay, so the number is 7. The number is 7, 0. The conversion for 7 is 1, 1, 1. That is from the octal to binary. While for the 0 is 0, 0, 0. Okay, having that, you combine the numbers. So we will have 1, 1, 1, 0, 0, 0. Okay, in a group of 4, so the first group is from that point, then add another 2 zeros on this other side. So 1, 1, 0, 0, this is equivalent. Just as you can see from the table, this is 8, while 0, 0, 1, 1 is equivalent to 3. This is equivalent to 3. Therefore, the final answer will be 38 base 16. It's that simple. So the most important part is ensure that you are conversant with the table conversion for the octal to binary. You can look at the other example, then this particular one where we have the table for conversion for octal, binary, and hexadecimal. It is that simple. And guys, if you are not subscribed to this channel, kindly subscribe. It's free. And if you at all you have any query or any question or any clarification that you need or any suggestion regarding this particular work I'm doing, kindly share it on the comment section. I will get back to you as soon as I see your comment. Thank you for taking time to watch. Have a lovely day.